Okay, people, today we are working on unit 5.6. 5.6 is very, very, very similar to 5.5. Okay, we are still working on solve quadratic equations. Solve quadratic equations by completing the square. Okay, very similar to what we did in 5.5. But we're going to make it just a little bit more difficult. Okay, so we're still on solve quadratic equations by completing the square. So, all of your instructions are obviously going to say to solve. Okay, and we only have 2 examples for this one. Okay, so solve quadratic equations by completing the square. If you have the equation 2x squared plus 8x plus 14 equals 0. 2x squared plus 8x plus 14 equals 0. Now, these are a little different than what we did in 5.5 because they have leading coefficients. So what you're always going to notice about these equations for this objective is you can take out a GCF. So if you can take out a GCF, you should. Okay, so we would factor out a 2. Left behind would be x squared. Oh, I'm sorry. What did I do here? Sorry, hold on just a second. Sorry. Oh, no, we're good. Sorry. X squared, I'm sorry. X squared. Nope, I'm not good. Sorry. No, I'm not. Sorry, I was thinking about explaining this to you a different way, but I apologize. Okay, first thing you want to look for, is this a perfect square trinomial? No. So, since it is not, automatically, we need to move over the 14. So the first thing I want you to do is take over the 14. So 2x squared plus 8x equals negative 14. So first thing we want to do is create that space. Okay? Yes, I recognize that we could have taken out a GCF, okay? But it creates a couple, it makes it more difficult when we do complete the square. So first start by making your space. Then take out a GCF. So 2 left behind would be x squared plus 4x, we still have that space, equals negative 14. Okay, now that I have that space, now I can complete the square. So remember, we take the middle number.
Wait, so you have to...
So you want to create the space first.
But you have to take out the GCF.
We do have to take out, no, we take out the GCF after. Okay? If you took out the GCF first, then I will show you both ways. Okay, if you took out the GCF first, you'd have 2 times x squared plus 8x plus 7. Okay, then if you moved that over, when you move that over, you would have 2x squared, oh sorry, that's a 4. 2x squared plus 4x. When you move it over, you would have to multiply it back through by the GCF.
No, I mean like you can't fill the blank spot before you take out the GCF.
No. The only way this works is if you have a 1 as a coefficient in front. Okay, you have to have a 1 in front. Yes, Sue?
When you GCF the 2 out, couldn't you have taken out next too?
Right here? Okay, you could, but remember I'm completing the square. So this is not actually, I take that back. You're not actually taking out a GCF. We are just taking out the coefficient attached to x squared. A little bit more clear. Technically, yes. It is a GCF, but it's a GCF for the whole thing, not, because you're right, you could take out an x, but we're trying to complete the square, so we're trying to make a square equation. So you take out the coefficient attached to the x squared. We'll be a little more exact there. Say again? Your brain hurts. Okay, sorry. So take out, so we're going to do middle number divided by 2 and squared. So your middle number divided by 2 is 2 squared. So remember, this 2 is going to end up being inside your binomial. Okay, so here, what are we actually going to add to both sides? Add a 4. But what did I really add here? 2 times 4, which is actually 8 on the other side. Okay, you're actually adding an 8 because I originally took out a 4. So here, you have to multiply back through on the other side. Okay? No, I originally took out, right. So since I took out a 2, you have to multiply by the 4. So on the other side, you have to add an 8. Yes, Sam?
So it always just be the original, or was it in the middle in the first place?
This?
Yeah.
It's always this middle number.
No, because you're adding 8 to the other side, and it was 8 in the middle.
No. Oh no. That is pure coincidence. Yeah, no. That's a new one. I've never heard that theory, but no.
Wait, what?
That is pure coincidence. I'm not even going to tell you because it's wrong. No. Great. So we still have the 2. Then you have an x plus 2 quantity squared equals negative 14 positive 8 gives you negative 6. Now I can solve. Okay, now where do I start solving here? Divide by 2. So we'd have x plus 2 quantity squared equals negative 3. Now to undo the square, root both sides. Make sure and put in your plus or minus. So we got x plus 2 equals plus or minus what? I root 3. Okay, now should I split this up or can I keep it together?
Keep that.
You can keep it together. How do I move this to? Subtract it. So x equals, remember the real part should always go first, so negative 2 plus or minus I root 3. That is your answer. Okay? Negative 2 plus or minus I root 3 is our answer. Questions on how I did that? Okay, we're going to do another one just in case that was a little unclear. Sorry, I apologize. Okay, for number 2, if I give you the equation 3x squared minus 36x plus 150 equals 0. Now, anytime I tell you in the instructions, solve by completing the square, you are always going to have to find the C number that works in there. So no matter what you do, you're always going to know I need to first create that space. Okay, so first create this space. So subtract the 150, so 3x squared minus 36x equals negative 150. Then take out the number attached to the x squared. We're not going to call it a GCF. We're going to call it the coefficient of the x squared. So, say it again. No, we're not taking out an x. Okay, I know, but I want you to factor out just the number attached. I know you're taking out from both, but we're going to call it, instead of saying GCF, because then you would take out an x, we're going to call it the coefficient of the x squared term. Or you're taking out an a. Okay, say it again. Because when I said take out a GCF, technically between these two, there's a number and an x in common. Right, we're just taking out the coefficient of the x squared term, so we're taking out the a value. So 3 multiplied by x squared minus 12x, we still created that space, equals negative 150. Okay, to fill that space, remember, we're also going to have to add it to the other side. Okay, so fill that space, we take the middle number, divide it by 2, and square it. So negative 12 divided by 2 is negative 6. Quantity squared, so what are we going to add? We are going to add 36 to the left side. What do I add to the right side? 3 times 36, which is 108. Okay, so when we're adding to the right side, you have to see if you multiply by anything. Okay, so here, we still bring down our 3. Don't forget that coefficient in front. Okay, a lot of people will just skip it. You cannot just skip it. Okay, 3 times, we know that this was x. This one comes from minus 6, quantity squared, equals negative 150 plus 108 is negative 42. Then to get 3 away, we divide it. So x minus 6 quantity squared equals negative 14. Notice how these always come out nice numbers, okay? They're supposed to. So if you don't get like a nice number that divides correctly, you might have made a mistake. So check your work again. Okay, now root both sides to get rid of the square. Place in a plus or minus. X minus 6 equals plus or minus I root 14. Okay, nothing else can come out of there. Then to get rid of the 6, we add it to both sides. So x equals 6 plus or minus I root 14. Now, that is perfectly fine to write it that way, but understand on a test or a quiz, if you saw this as 6 plus I root 14 and 6 minus I root 14, those are comparable. Okay, these are two answers. Question, Sam.
How did you get 108 on
3 times 36 is 108. Yes.
Why do you multiply 36 and 3?
Why do I multiply it? Because I took out the coefficient, so you have to multiply it back through. Because really, if I multiplied this all out, I would be adding 108. So if you add it to one side, you have to add it to the other side. Yes.
So, are you sure that what Sam mentioned is just because 36 is the initial equation, and then it's 36 at the end?
I would not count on that. That's not a hard and fast rule. Yeah, I just want to. It's coincidence here, and I totally see where. I've never thought of that before, but I'm pretty sure it's just coincidence.
No.
Okay, homework for this objective. Okay, listen, you guys are doing worksheet 6. It is numbers 1 through 21. Now, this worksheet is not in your green workbooks, okay? I will give you this worksheet, okay? So I will give you this worksheet. Yes, sir.